today is quadratic formula. And we're going to spend a couple days on this. So today we're just going to do basic stuff with equations, and tomorrow we're going to attach some situations. But you can literally use this to solve any quadratic equation. You can't always factor something. You can't always use square roots. Maybe the graph doesn't cross the x-axis if we have an imaginary solution, but you can always use the quadratic formula. Now, the key to this is your quadratic has to be set equal to 0, which we're going to have to do that in a couple of these questions before you identify the a, b, and c values. But a is just whatever's in front of your x squared, b is just whatever's in front of the x, and then c is just your plain number. All right, so all you're going to do here, this is a giant fraction. The x value will be equal to negative b plus or minus, this all on the top of a fraction, and then a big square root. This is b squared minus 4ac, and then that entire thing is over 2 times whatever the a value is. And I'm not going to lie to you, some of these answers look super weird as you've gone through and you've done everything correctly, but they might have a radical. And we've had that in some of the questions we've done over the last couple of days, like it had a square root or something in it. That's fine. Sometimes it cancels out. It just kind of depends on the question. But if you can identify the a, b, and c values and plug them into that, then you're good to go. So we're going to first, if we're going to solve a quadratic equation, first thing I'm going to do is just set this equal to 0 real quick. And it doesn't matter if you're using the quadratic formula, if your squared term is positive. I know we kind of tried to focus on that when we were factoring, but if you're just using the quadratic formula, it doesn't matter if the a value is positive or negative as long as you identify it correctly. All right, so I'm going to plug a, b, and c into this formula, so I got to know what a, b, and c are. So if you looked at that equation, set equal to 0, what would you tell me a is? What number?
3x.
Just a number, just 3. Just 3. What's your b value?
1 for x.
What's my b value? It should be, this is just like a little negative. There's no number written in front of that, right? So I'm just going to say that's negative 1. We don't want any variables to plug into this, just numbers. All right, and what would you tell me c is? Negative 4. So if it has a subtraction sign in front of it, you want to look at that like it's a negative number. Once you have that, you're just literally plugging it into this formula that I have up here above. Okay, now my b value is negative 1. So opposite of b would actually be positive 1. Plus or minus square root. B squared would be negative 1 squared. 4 times my a value, which is 3, times my c value, which is negative 4. Whole thing over 2 times the a value, which would be 2 times 3 for this question. Okay, now I don't generally do this all in one step. Okay, so here's what I would tell you to do. I'm going to keep my b value, which is positive 1 plus or minus. Do not involve the square root. I'm going to grab my calculator. Okay, I'm going to do negative 1, whoops, in parentheses and squared. So I'm not using the square root. I'm just going to type what I wrote under the square root. And then it'd be minus 4 times the 3 and then times the negative 4. I'm just do that all in one step, but I'm not including the square root. Just do that in one step. And then that is 49, which will be nice for us when we do this question because that's a perfect square. And then the bottom, just 2 times 3 should give you 6. And then we're going to see what we can simplify. Okay, anybody know square root of 49? 7. Okay, now, do you see any square roots or i's in this? No. Okay, so if you don't see any square roots or i's, you can actually simplify this. So like on the top, I'm going to do 1 plus 7 and divide that by 6. So I'm literally just doing 1 plus 7, that's 8, divided by 6. And then that's not a nice number to divide, but I can reduce that fraction. So both of those guys are divisible by 2. That'd be 4 over 3. Then my other answer, I would do 1 minus 7 divided by 6. So that gives me negative 6 over 6, which that does actually divide out nicely. So that would be negative 1. So then those are my two answers, 4/3 and negative 1. If you plug those back into the original, should make both sides of the equation equal. Does anybody have a question? Okay. let's try the one next to this here. First thing you should do, if it's not already, is set it equal to 0. So in this next one, I'm just going to add the 9 real quick. And let me come over here to the side so I have a little bit more space. So it'd be x squared plus 6x plus 9 equals 0. Then once it's equal to 0, that's where you want to identify your a, b, and c values. Okay, tell me what a would be for this question. 1, right? What's your b value? 6. And what's your c value? Good. Okay, we're just going to plug these in, all right? That's all we're doing. Let me pull that formula down so you guys can see it on the screen there. All right, opposite of b. So I'm going to do -6 plus or minus square root 6 squared, and then 4 is part of that formula. You see the 4 in the formula. So 4 times our a value, which is just 1, times our c value, which is 9. The whole thing over 2 times a for that question is just going to be 2 times 1. Okay, now like I said, I usually kind of do this in 2 steps. After I set it up, I'm just going to leave that -6 plus or minus, and then I do not include the square root when I type this into my calculator. I'm just typing what's under the square root. So I'm going to do that 6 squared, that should be 36, 4 times 1 times 9. Now the thing with that, if you do 4 times 1, that's 4, right? Times 9 is 36. So this makes sense because I'm getting 6 squared, which is 36, minus 4 times 9, which is 36, which this is then just 0. The bottom of that fraction, 2 times 1 would be 2. Anybody know square root of 0? 0. Okay, now this is kind of weird. So if I did -6 plus 0, or if I did -6 minus 0, it would be exactly the same thing. So what this means, this question just has one answer. So this would just be literally -6 over 2. Because if I add 0 to -6 or subtract 0 from -6, exactly the same thing. So that should just be -3. That would be a case if we were to graph that, just the vertex would touch the x-axis. Okay. Anybody have a question? Is it so hard? Is it that bad? If you had the formula in front of you to look at, I think you could do it. All right. I'm going to do one more, and I'm going to give you a little trick on this one just if you want to. You do not have to do this, but I'm going to set this equal to 0. You do want to do that first. All right, so I got 2x squared minus 36x, and then plus 212. Okay, before I do this problem, does anybody notice anything about all the terms in that quadratic equation? They all, no, not all, but the 212 doesn't have an x. Do they have any numbers in common? 2. You don't have to do this. You can use the numbers in the problem, but if you want to use a little bit smaller numbers to work with, it's totally valid. If you want to just go through, divide everything by 2 real quick. You don't have to do this. You can use those numbers in your lovely quadratic formula, but I would maybe recommend if you see a greatest common factor, just so we're working with smaller values, just to make it a little bit less work. It's totally up to you though. 212 divided by 2 would be 106, but those two equations would have exactly the same solution. You don't have to do this, but if you do, you just work with a little bit smaller numbers when you plug them into that lovely quadratic formula. All right, so if I get rid of the 2, now my a value is 1, my b value is -18, and my c value, I know it's kind of big, but it's 106. Okay, now, you guys don't have to do this. I'm just going to write the quadratic formula so you guys can see it on the paper while I go through here. Now, I'm just plugging these into that lovely quadratic formula. I'm going to grab my calculator here in a second. Now, very important, the opposite of b. This is -18, so the opposite of that would actually be a positive 18 out in front, plus or minus square root, -18 squared, 4 times my a value, which is 1, times my c value, which is 106, everybody over 2a, which is just going to be 2 times 1. All right, and then like I was telling you guys, I just keep whatever's in front of the square root, so the 18 plus or minus, because it's got 2 answers, so we got to have the plus or minus. And then I don't type the square root, I just type what's under it. And if you type it right in like I have it, -18, that's in parentheses, squared, that'll make sure to cancel out the negative. 4 times 1 times 106. I'm literally just letting the calculator do this work for me. Now, under the square root, so I didn't take the square root, I just typed in what I had underneath there, this is -100, the bottom of that fraction, just 2 times 1 would be 2. Okay, anybody know what you'd write for square root of negative 100? Do what? What would be the square root of just 100? 10. Well, so what if it's negative 100? What would you write? 10i. That's it. Okay, this is going to be imaginary. So 18 plus or minus 10i over 2. Okay, now here's the deal. It has to be all three of these, right? All right, if I have 18, I have 10, don't mess with the I, and I have a 2. If all three of those are divisible by 2, which they are here, you can reduce that fraction. So you have to, it has to be all three, all around the plus minus, all three of them. If they're not all three divisible by 2, then don't do it, but they are here. So my actual answer to this question, 18 divided by 2 is 9. You just keep the plus or minus, and 10 divided by 2 is 5, and then you keep the I with it. So this has two imaginary solutions, 9 plus 5i and 9 minus 5i. So you can get, like we've had here, we've had one that was the perfect square. We had two answers. We had one, the square root of 0. This one had a square root of a negative, so we ended up having an imaginary solution. So it just depends on the question what you might get. Okay, yeah, go ahead. I'm just going to try 2 more with you guys on the back. Now, these are going to be a little bit trickier, and I'm going to ask you to do 2 things on these questions. All right, this says give an exact solution, and then I'm going to have you give me an approximate solution. Okay, now I got to set this equal to 0 first real quick. So I'm just going to add the x squared to the other side. Now on the other side I already had a 2x squared, so if I add one more to that, we'd have 3x squared plus 4x minus 2, and then that's equal to 0. Okay, now here, like 3, 4, 2, there's no greatest common factor, so I'm not going to divide and get rid of anything. We're just going to work with these numbers, which isn't bad because they're kind of small anyway. A values, whatever's in front of x squared, just the number, 3. B values, whatever's in front of the x, which is a 4. C values, the plain number, and if it has a minus in front of it, you want to think about that like a negative number, so that would be negative 2. Okay, I'm going to put that formula. So negative b plus or minus square root b squared minus 4ac, just so we can see it on this side. Everybody over 2a. That's what I can use to solve that equation if I can plug those numbers in. So for this lovely problem, opposite of b would be negative 4 plus or minus, and then under my square root, the b value is 4. We're going to square that. Minus, there is a 4 that's part of the formula. A is 3, c is negative 2. And then the whole thing is over 2a, so 2 times 3 for this question. All right, and then again, I'm just going to show you on my calculator, I'm not including the square root, but I'm going to simplify that mess that's under the square root. So we're going to square 4 minus 4 times 3 times negative 2. And I'm just kind of putting parentheses around each of my lovely numbers there. Now, unlike all the questions previously that we've done, the first question I had a square root of 49, that was a perfect square. Second question we had 0, that's a perfect square. Last question we had negative 100, that's a perfect square in imaginary land. This 40 is not a perfect square. Okay, so I'm going to put this 2 times 3 on the bottom is 6. Now the part that's a little bit tricky here, you have to, if you can, break down the square root of 40. So that's what we're going to do here. So to the side, tell you what, I'm just going to come over here, just use a little bit of space. Tell me 2 numbers that if you multiply them together, you get 40. 4 and 10, perfect. Okay, so 4, 2 times 2, 10, 2 times 5, right? Broke the 40, broke the 4, broke the 10. Now, you have a pair of 2s. I did not get any other pairs from that 2 and 5, so I would just put those back together. So 10 is going to stay under the square root, and 10 does not break down under a square root. So the square root of 40, this is equal to 2 times the square root of 10, right? I'll show you on my calculator real quick. Like if I did square root of 40, and I did 2 times the square root of 10, same garbage decimal, so those are equivalent. What I want to do is I want to replace that where I had the square root of 40 like over here. So we have -4 plus or minus 2 roots of 10 over 6. Okay, now this is really super tricky, so I'm going to really try to emphasize this. It has to be all three of these. Don't touch the radical. Don't even look at the radical after you simplify it. If all three of those numbers around that plus and minus symbol are divisible by something, you can reduce that. So I'm going to be able to do that here. Those are all even numbers. Don't change the radical. Don't touch the radical. Just those three numbers. So everybody's divisible by 2 here. So -4, if I divide that by 2, this would just be -2. Okay. This is a little weird. 2 divided by 2 would be 1. You likely, I'm just going to lightly write that, but you likely would not see a 1 written in front of that. You would keep the square root of 10. Do not change what's under the square root. The bottom of the fraction then would be 3. Just divided each of those 3 pieces by 2. So -2 plus or minus 1 root of 10, or just root of 10 over 3. Okay, now this is what we call an exact answer, because I have exactly, what that's equal to. I didn't round anything. I reduced a little bit of a fraction, but that is what we call an exact answer. Now, on all the other questions we've had so far, we haven't had anything left under a square root, so we haven't had to do this. But if you have an exact answer, you can also write an approximate answer. So to do an approximate, oh, I can't spell. To do the approximate answer, all you're going to do is type this into your calculator. I'm going to do -2 plus the square root of 10, and then I'm going to divide that by 3. And let me grab a homework paper. I want to see what it asks you to round this to. Nearest hundredth. I'm going to go 2 decimal places. So if we were looking at this on like Desmos or something on a graph, we graph this, and these would be the places it would cross the x-axis. I'm just going to have you guys go 2 decimal places to approximate this. So approximately 0.39 is where that would cross the x-axis. You have 2 answers though for the approximate, because you also have -2 minus the square root of 10 divided by 3. So I'm doing -2 minus square root of 10, and then I'm going to divide that by 3. And so my other approximate answer is about -1.72. So those would be my 2 places if we were looking at it. The exact answer is going to include a radical if you have it. So approximate means I'm basically just approximating that square root of 10. But you just do that on your calculator. And then we're going to do one more question real quick. We're going to set this equal to 0 again. So make sure before you identify your a, b, and c values that your quadratic equation is equal to 0. And I would just check to see if I could work with smaller numbers if they had anything in common. Like 2 and 6 are both divisible by 2, but 7's not. So I can't get rid of anything there. So my a, b, and c values, I got a is 2, b is 6, c is 7. So I'm going to do opposite of b, which would be -6 plus or minus square root. B squared would be 6 squared minus 4 times your a value is 2 times your c value is 7. I'm just plugging it into that formula. Everybody over 2a, which would be 2 times 2. Okay, I do this in 2 steps. I'm going to set that up, and then I'm going to grab my calculator and do what's under the square root. So 6 squared minus 4 times 2 times 7. So we have -6 plus or minus this, oops, I just wrote that wrong. -20 is what I got when I simplified that. Still under a square root because I did not take a square root. And then this is very similar to what we were doing with the imaginary numbers. We're going to break down the -20 because it's not a perfect square. Like we had a -100 on the front. -20 is going to come over here. Alright, now, if you have a negative, I would just automatically take an I out in front of that, and then we'll figure out if we can break down the 20. So the I gets rid of the negative symbol. Square root of -1 is I. That's why if I can remove the negative by taking the I out in front. And then tell me 2 numbers that multiply to give you 20. 10 and 2. Perfect. Okay. Then we got 5 and 2. So we got a pair of 2's. We broke the 20, the 10, the 5's left underneath. Okay, so all simplified, we'd have 5 outside with the I, and then, oh, no, fail. Sorry, 2 outside with the I, and then the 5 left underneath. The pair comes out in front, the one that's by itself stays underneath. So I'm just going to go back over here and replace that negative square root of 20 with how we simplified it. So this would be negative 6 plus or minus 2I radical 5 over 4. And this doesn't always happen, but I tried to do one of these on each of these questions. It doesn't always happen, but sometimes you can reduce. And in this case, you can. Do not touch the radical. You're looking for all 3 of those numbers on the top and bottom around the plus and minus symbol. And again, all these guys are even, so you can reduce this. I'm just going to divide each one of those pieces by 2. So I'm going to get negative 3 plus or minus. This would just be an I. Do not touch the radical. That should say square root of 5. The bottom would be 2. Okay, this is your exact answer. And I'm just going to make a note. Because I is imaginary, right? It doesn't exist. We would not see this on a graph. It's not going to cross the x-axis if we were to graph this quadratic. So if you have an I, which I do have an I here, right? If there is an I, there's no approximate like we did on the last question if you see an I. So I would just give the exact answer for that. So if it asks you to do that, you would only do that if you don't see an I. If you see an I, you don't approximate that because you can't type that into the calculator. I can type a square root of 10, but I can't type in I radical 5. That doesn't have a situation where you would round that to a decimal. Is anybody having a question? And I will give you the quadratic formula. You just have to remember, set it equal to 0, plug those numbers in, and then simplify what you can. I tried to do every possible situation I thought you could run into. So the front, we had like real answers, we had one answer, we had imaginary that were nice, perfect squares, and then on the back we practiced where they did not have nice answers. So that's what I'm going to have you guys work on